you've done this before. So the first one of the measures of central tendency that we're going to talk about is known as the mean. Does anybody or has anybody ever heard of the mean before? What does it mean? Average. Okay. So how do you calculate the average? Say that again, Tasha. You were saying it under your breath, but I saw you.
Don't you just add them all together and divide how many, like, 5 different numbers you divide?
Absolutely. Yeah, you get it right. So I'm going to give you a set of numbers right now. Okay? I'm going to give you the numbers 24, the numbers 25, the numbers 37, 38, 34, and 35. Nice little short, small, 6 numbers. How would you find the average or the mean? You'd add them all together and divide it by, as Tasha told me, divide it by how many there were, and there were 6. Anybody got the answer? 32.16 repeating is the average. Now, does anybody know what those numbers or where those numbers came from? Huh? The hockey players? Close. It has something to do with hockey, that's for sure. This was one of, we gave up 25 shots and had 24 saves. That's the most important one. 38 shots, 37 saves, 35 shots, 34 saves. That's what it's from. It's from this weekend's. That's Bray's saves and goals. He allowed 1 goal per game, is what he did. So if you added them together and divided it by 6, like Tasha told me to do, it was 32.16, which does not actually mean anything, because I lumped together the saves and the shots. Now, if I wanted to, because me being a coach, could I have taken all of my goalies' saves for the entire year and all of their shots against for the entire year and average them together to figure out, is that something that we could use as a coach? Absolutely. We use that all the time. We look at how many shots we give up. For example, just so that you have an idea, at one point in our JV season this year, we were giving up close to 50 to 60 shots a game, which is horrible, just so you know. We want to keep that number around 20. So 60 as compared to 20, not a good scenario. Okay, so we needed to work on some things, and we got that number down eventually. But that's one of the reasons, or one of the things that we actually use this for. As a coach, we look at that to figure out we're giving up this, an average of this many shots a game or this many goals against in a game. Okay, that's an important stat. Then we figure out the average of how many goals a game we get. As long as that goals per game is higher than the goals against per game, then we should do okay. Okay, that's just one of the measures that we look at. The next one. What's a median? Middle? The number in the middle? Now, we're talking about numbers, and it's the number in the middle. Are there other medians in your life? All of you in here drive, don't you? Isn't there a median in the road? Or maybe there should have been, instead of hitting a light pole. Like our bus did on Wednesday. Okay. Yeah, it's the middle number. What do you have to do to get it?
Put all your numbers in order from least to greatest.
Okay. Do you have to go least to greatest? Or just in order? Okay, so that data set, what was the smallest number?
24.
Then? Okay. And? So the middle number goes where? Huh? It's in between these two right here. Okay, what happens is when you have an even number of data points, you got to go in between the two middle ones. Right now, these are the two middle ones, 34 and 35. What number's in between 34 and 35?
34.5.
Right. That's the median. Okay? The median has to go is a certain number that needs to go in between those two things. Okay? And if you have an even number of data points, then you need to average the two middle ones. Right? That's what a lot of people do, is that they add those together and divide by 2. Okay?
It's not right or wrong.
What?
Adding them together and finding the mean.
Oh, absolutely not.
Okay.
That's perfectly fine. Okay? Is everybody okay with that? Have you guys done that before? Okay? What's the other measure? Mean, median, mode. Anybody remember what mode means?
Most.
Yeah. Most is usually the word I associate with it too. On our particular data set that I gave you, do we have a mode? Was there a number that occurred more than once? No. So for this particular thing, there was no mode because there wasn't a number that showed up more often than the other ones. They were all the same. If that occurs, then that happens. What if you have where you have a set of data or set of numbers and 2 of them show up the same amount of time and they're the most often? Do you have 2 modes then? Yeah, you do. Okay? So a mode is the one that occurs the most often. Now out of those 3, those are the big 3 that you guys have done before. Which one of those, if you had a data set, like the shots and saves that I just gave you, which one of those would be the most beneficial? Which one would you use if you were to report it out?
Shots.
Okay, I mean between the 3. Which one is the most beneficial to you? The mean, the median, or the mode? The mean? Why else?
Well, these are kind of like, the mode just tells you like 2 of your shots, like say out of your 2 games. And in the middle, it's just 2 numbers. This one's like all of them, so it gives you more like a bigger variety, I guess.
Okay. Anybody else want to go with something different? Most of you like mean. Me personally, I like the mean too. Okay. What if I throw what they call an outlier in there? Remember what an outlier is? What's an outlier? A number far away? Number far away. Like a number that was over in like Fargo? Is that far away? 1, 2, 3, and then like 50. So like in our numbers that we have 24, 25, 34, 35, 37, 38, and then all of a sudden, what if we had 80? Would that be considered an outlier? Yeah. What if we only had like a number 5? Would 5 be like a lower outlier? It's closer to them, but it's still on the outside edges, right? How does an outlier affect those other 3 numbers? Does it affect the mode at all? No, I don't think it does. What about the median and the mean, though? Would an outlier affect those?
The mean, it would throw away off.
It would throw it off. Depends on how many data sets you have, though, right? If I had, let's say I went through and listed out our goalie's shots and saves for every game this year and listed them out, and then all of a sudden threw a random number in there that was an outlier, would it affect it a lot? Well, now I'm dealing with more data sets as compared to just the 6 numbers I gave you before. If I only give you the 6 numbers like that and I throw an outlier in there, it's going to affect it more than it would if I had more points. You see what I mean? Will it throw off the median a little bit? Maybe. Because of positioning-wise, it might have 1 extra number in there to throw it off, but that would be it. Do you guys know what that for an outlier, that's all it's doing is just throwing off your data a little bit? And sometimes they throw out outliers. They throw them away because they're something else happened or something maybe that they couldn't control. Another one. This one's more of the measures of central dispersion, is known as the range. Now, you've already dealt with domain and range, but this is, and it's a little bit like that. Anybody know what the range is? Say that again, Matt. Subtract the biggest from the smallest. So highest, I'm going to use highest, minus the lowest. You know why people get it wrong? They list it out like they list 38 to 24. They list it like that. They put the low to the high. They say 24 to 38. That's how they list it. Which realistically in our data set, 38 minus 24 is what? 14. The range was 14 because we went from 24 the lowest to 38 the highest. We went up 14. Now, second hour made a comment about how he thought, well, can we have a negative? And I thought, well, yeah, I think we can. Can't we? Can't we go down on different data sets? Let me give you an example of something like that. Today's high is supposed to be in the 20s, which it is right now. Overnight, tonight, or tomorrow night, one of those two, it's supposed to be negative 10. Only for a couple more days, guys. Then it starts getting warmer. But overnight, like in these next couple nights, it's supposed to get minus again. Could I have a range that's negatives? We deal with that in this part of the country all the time when it talks about weather, don't we? We could have that happen. So, yes, it is possible for you to have a range that's negatives. Okay, but it's the highest minus the lowest. Then, the new one that you guys are going to probably, and maybe you have not done before, is known as the standard deviation. Now, standard deviation is probably the new thing that you are going to have to figure out. There is a formula for it, and I'm going to give that to you today. But the standard deviation is, we're going to use it more in the next couple sections when we talk about normal distribution curves. And they talk about this many standard deviations away from the mean and so on like that. We talk about bell-shaped curves. That's what we're going to deal with when we get to there. Today I'm just going to show you how to figure out that standard deviation, but later on we're going to deal with how and when we use it. Okay? It's denoted by this symbol. It's a Greek letter of the alphabet, meaning sigma. And here's the formula. It's a tedious process, that's for sure. We got x1 minus x bar squared plus x2 minus x bar squared plus x to the n minus x bar squared, all divided by n. I want you to notice that the n is underneath the square root. That is important. And now, I need to talk to you about what these numbers are. This n right here stands for how many terms you have. So in our problem that we had with the shots and saves selection thing, how many numbers was it that we dealt with? 6, right? We dealt with 6. If I went back and looked at and listed out all of Peyton Manning's touchdown throws throughout his career, would I have a lot more than 6? Yeah, because he's been in the NFL for like 15 years. So I'd have 15. Okay? This number right here, this x bar number, that is the mean. That's the symbol for mean. X bar is mean. And then these numbers right here, this one, and so on, are the data points. How many of those data points do you have to do? Depends on how many points I give you. So for instance, if I use the shots versus saves thing, how many different pieces would I have underneath the square root? 6, because I gave you 6 numbers. What if I gave you 15? How many different ones would you have underneath there? 15. What if I gave you 5? How many would you have underneath there? 5, and so on. Now, the problem with this, and this showed up this morning, we did 2 problems like this, and half the people got it right, and half the people got it wrong. And it's all in how you type it into your calculator. Your calculator is going to do the grunt of your work for you, but if you don't type it in right, it's going to give you the wrong answer. Okay? So, on that problem that we had, we already know what the mean is, right? Don't we? I think if I remember right, Isaac, you gave us the mean, did you not? The first number was 24. That was the first data point, if I'm going to go in order. Minus, what was the mean again? 32.16? We'll go there. That's fine. Squared plus 25 minus 32.16 squared plus 34 minus 32.16 squared. See how I'm getting all the numbers from the data points that I typed in. That's what I'm doing. What's the next one? Yeah. Squared. And then after that, I just keep going, right, till I get all of them. Now, I ran out of room. Okay, so here, I'm just going to extend this down here. This would have been 37 minus 32.16 squared plus 38 minus 32.16 squared. So how many of those how many of those groups should I have had? 6. Why? Because there were 6 numbers that I gave you. What if I would have done Peyton Manning's touchdown throws over his career? Would I have had a lot more? Yeah. Okay? Now, what number should be on the bottom? 6. Right. Now this, just so that you guys know, wraps around to here. That's what's happening. Okay? I just wrapped it around because I ran out of room. Alright? Now, this is what I'm referring to by chunking it, because on the calculators, if you have a newer 84, you should be allowed to type everything in and see it all and everything looks fine and dandy. If you've got an older 84, it's going to be tricky, because if you don't put enough parentheses in here, you're going to get the wrong answer. Trust me. It happened this morning. I only got 1 or 2 people that actually got the right answer this morning, only because they didn't type enough parentheses in. Do you remember last chapter how we had those finance problems, and I told you that you could chunk things on the calculator? You remember that one where it was the P parentheses 1 plus R over N, and we chunked it? I might want to do that here too. What I would do if I were you is this part right here, all this that's right here and here, do that part first. So go parentheses 24 minus 32.16 parentheses squared plus. Get all that first. Once you get that number, then you hit divide by 6. Get an answer. And then you've got to take the square root of the number that you have right there. And how you get answer back into the problem is once you hit square root, it should come up like that. If you want the previous answer, you hit second and then the minus button. Or the negative button, which is down by the period. If you do that, we should get the right answer. Okay? If you want to risk it and type it all in at one shot, you're going to need more parentheses than normal. Because what happens is people try to put it in exactly the way it looks, and they start by square root, and then they type all that stuff in, and at the end of this, they go divide 6. Now, if I were to do that and type it in that way, the only piece that's getting divided by 6 is this piece right there, not the entire piece. So you would need an entire parentheses here and here. Then, especially on the older calculators, you would also need another parenthesis here and here. So if you use the older calculators and type it in, you're going to need a triple shot of parenthesis at the beginning. And then a double shot here, and then a single one at the end, in order to get it right. Me personally, I think chunking it would be better. Anybody have the number yet?
Yeah, 5.58.
5.58. We're going to go to the hundredths. So 5.58. Anybody else get that? Corinna? Okay, we got a couple of people that got it. That's what we got this morning too. That is the right answer. All right. Now, I'd like to do another one of those because they are more tricky than anything you've ever done before. Let's do one out of the book from your assignment. So that way I give you a free one. So if you look on page 747 to 748.
Is there a lot of these in
No, there's not. And by the way, that assignment is not accurate. I forgot to type the word evens. 4 through 22 evens. Michaela, would you pick a number that deals with standard deviation? Nope. No, you don't need that one. Just down here.
22.
22? Okay. For 22, it has the numbers 184, 192, 173, 181, 199, 65, 190, 188. And the directions for this problem say identify the outlier in the data set, then find the mean, median, mode, range, and standard deviation of the data set when the outlier is included and when it's not. Okay? So, first and foremost, which one of those numbers is not like the other? Just which one isn't the same? 65? Okay, now. And putting this into context for me, I could actually use these numbers, and these numbers have shown up for some things that I do. As you guys may or may not remember, I do teach college algebra for the university. I've seen test scores like that on my final, where I've had a lot of good ones because my final is worth like 250, and seen some that are up in that area, and then a 65. I've seen that happen because they go in and they just tank the final. All right? That's the outlier. Okay? Now, I am going to change the directions just a little bit because finding all that stuff with and without especially the standard deviation, that's a lot of work. So I want you to find it with the outlier. So you don't need to do both. Just find everything with the outlier. Okay? All right, Madison? Madison, out of all those numbers that we have to find, which one would you like to find first? The mean, median, mode, range, or standard deviation? The mean? Me too. Do you know why I want to do the mean first? Or why do you want to do it? That's what they first asked for? Okay. I like to know the mean first because I need it in order to find the standard deviation. Okay? So in this particular problem set, we need to add all those numbers together and divide by how many there were, which there are 1, 2, 3, 4, 5, 6, 7, 8 of them. So we're going to divide it by 8. What do we get?
171.5.
Now, because of that outlier, if I notice the number that Brooks gave me, he gave me 171.5, which is lower than every other number with the exception of 65. Had the 65 not been in there, would my mean be higher? Yeah, probably be in the 180s somewhere, right? Which would probably be a more accurate account of the data. But being as it is, It wasn't. Okay, which one do you want to find next?
Median.
Median? How do I need to do that, Brianna?
Everything in order.
Okay. So if I do that, 65 looks like it's the lowest.
173.
173.
181.
181.
184.
184.
188.
188.
192.
192.
And 199.
199. And there's a problem with that. $190. You missed the 190 right there. Okay? Which I'm glad that you did that. Here's why I'm glad. Shaylin, do you think that if we would have left hers out, that one number that she accidentally missed, would that have affected our stuff? Good answer. So we got 8 of them. So that means what's half of 8? 4. 1, 2, 3, 4, right here, and shut the door. We got 184 and 188 in the middle. So what number is in the middle between 184 and 188? 186. Now I need you to think about this for a second. I want to know, after you thought about it for a second, which one of those two is a better representation of our data? The median or the mean? Okay, which one do you think? Why, Karina? Closer between the other numbers. So the outlier didn't affect it all that much this time, right? It may have shifted it a little bit, but not a whole lot. But the outlier sure as affected the mean. Okay? What about the mode? That's the next number up on the list.
There is none.
There is none. Why?
There's no repeating numbers.
There's no repeating numbers. Right. Okay, now the next one on the easy train, the range. And I don't remember who told, I think it was Matt who told us how to figure it out. You take the highest one, 199, minus 65. 134. The range is 134 numbers in between there. Had I taken the outlier out, I would have been sitting at a range of 26. Is that a little bit different number? 134 as compared to 26? You bet it is. All right, now comes the hard part. This is the part that is going to take you more time than any other part of the problem. Now it's time to find the standard deviation. Okay? So in order to figure out the standard deviation, you're going to take and you're going to do 65 minus 171.5 squared. 173 minus 171.5 squared. And you're going to keep doing that until you get the final answer. Okay? And then you're going to take that and divide it by how many numbers there were, which there were 8. Then you're going to take and square out that answer to come up with that standard deviation. And again, a little bit later on in the chapter, we're going to talk about how and what that standard deviation stuff was used for. Yes, Karina?
Does it matter, like, which number you put first? Like, does it have to be the lowest to the highest?
No. As far as the order, it does not matter which one you put in first. No. But you always want to go that data point minus the mean. You can't go the mean minus the data point. It's got to be the data point minus the mean. When somebody gets it, tell me what you got, and I'll tell you if you're right, because I already have the answer. Reese, what did you get?
42.
And I got 2 answers up there so far. I got 41.69 and I got 40.9. Anybody else have something different? Tasha, what'd you get?
I tried something different.
Tried something different, didn't work? I want to ask you a question as you guys are thinking about this, and some of you that didn't do it. When you have 41.69 and you have 40.9, are those relatively close? Yeah. What might be the difference if they did it the same exact way? What might be the difference in, or what do you think could cause that discrepancy of 0.79 away from each other? Could it be rounding? Maybe Michaela rounded differently than Reese, and so therefore that's why they're off a little bit. I heard somebody else just got this one right here, 40.9. Say that again, Matt. 41.09. And some of you are still clicking. I will give you a hint. I think the ones that got this number here probably didn't round a whole lot. And it's a little more accurate. Okay? That's what my calculator come up with for the answer was 40.9. All right? Now, that being said, if you're around that number, am I still going to mark it right? Yeah. Now, obviously, if you had something that was a little bit higher than that, that I probably would not have given credit for. But those numbers that are up there are pretty close. And a lot of it has to do with rounding. Granted, you're looking at me like you don't want to share your number, but kind of want to just to see what you did wrong.
40.59.
5.9, that'd be close.
If I rounded that 0.6, which still isn't close to 50. So I don't know how.
Yeah, it is. It's only 0.3 away.
But if you typed in the same things, how did we get different answers?
I don't know. Maybe you typed something in wrong. That might be. Earlier today, I was doing one with the goalie shot stuff, where it was. We were getting not the 5.58. We were getting like, I don't know, in the 40s or something like that, which is nowhere near what that should be. Now, again, that standard deviation, the only thing that we're going to do with it today is we're just going to find what the standard deviation is. We are not going to actually use it technically until a couple sections when we start talking about normal distribution. But as far as it goes for now, we need to try to find the problem. Okay? Be very careful with your parentheses and with how you calculate it, because it will be off just a little bit if you don't get it right or if you type a number in wrong. This morning I found somebody got it in wrong because their mean was 316 point something and he put 31 point something for one of the problems. So now all of a sudden it was just because they forgot to type a 6. They got the whole thing wrong. So be very careful with your numbers. That was the one that's going to take you the most work to do today. The rest of them, the mean, median, mode, range, I think you guys can handle that without question of a doubt. But that's standard deviation. It's time, labor intensive for that part of it. The rest of it, I think you're going to be okay. Does anybody have any questions on how to find those again? All right. So, on page, Lydia, what does it say for the page? 747? Okay. 747 to 748. 4 through 22 evens. And 26. Again, it's the evens part, if you look on the board over there, that I forgot to type in. Okay? So.